Good morning. Welcome to the video lecture for the subject Introduction to Artificial Intelligence. I am Dr. M.Hemalatha, Professor CSE Department, RMDEC Engineering College. This lecture is the continuation of the topics coming under production system. In lecture 4, we have seen the definition, applications, key components and features. In lecture 5, we have seen control strategy, and now we will proceed with the further things. In this lecture, we will be discussing the types of production system. As seen in the slide, we can broadly classify production systems into 4 types: monotonic production system, partially commutative production system, non-monotonic production system, and commutative production system. Monotonic production system, we will look into the description at the end. We will quickly get into it. Monotonic production system has a definition, it has key characteristics, the important concept of monotonic production system, and we will see an example for it for a clear understanding of the type 1. The definition goes this way: once a fact is inferred, it remains true regardless of the future changes or additions to the knowledge base. What does this mean? We know production system has 3 components. One important concept is component is knowledge base, and the knowledge base is going to have set of rules in it. Using this set of rules, we will try to derive something, and that something can be sometimes conclusions and sometimes facts. Like the fact, we know anything is called fact, then it should be true. At a later point of time, we find that there is some new information coming in. We consider that also. But because of we considering that new fact, it doesn't mean the old one is to be overwritten. The one which is already there is always going to be true forever. So the key characteristics of monotonic production system, the first type of production system, monotonic production system, are the conclusions are stable. You cannot invalidate the conclusions which is already done. Second characteristic, no backtracking. Even if there is new information which is available, the conclusions which are drawn will not be changed or revisited. And third characteristic is predictability, because we know I have a set of rules, I am going to derive, it could be a fact or a conclusion. So it's very clear. So the conclusions once made is going to be permanent. So you can have a high degree of predictability. Example for monotonic production system is our expert systems. Let us consider this medical expert system where I have a patient coming to a doctor stating that he has fever and sore throat. These are the 2 symptoms which are fed as input for the expert system, and this expert system is going to make use of the already existing set of rules, and it is going to derive a conclusion that this patient is having strep throat. But after 1 or 2 days or after a few hours, probably the patient develops a rash, and it is going to be a new new symptom which is seen in the patient. And again, to the expert system, if this symptom is going to be given, the expert system is going to give a similar fact or a conclusion, but whatever has been identified already, the strep throat, will not be erased. This is the type 1 monotonic production system. Type 2, partially commutative production system. We will look into the definition first. Let us continue with the partially commutative production system. The definition is, it's a production system in which a sequence of rules is used to change one state into another state, and then Any permissible permutation of those rules also delivers the same state. So what is commutative property? Commutative property is very important in marks. It states that the order of operations or order of the inputs doesn't change the output. Like if I add 8 plus 7 or 7 plus 8, the order in which I get the entry is not going to change the final answer. But R type is partially commutative production system. So what is this word partially going to do in our production system? This one ensures the two things. Here the system may produce different results when the rules are applied in different sequences. But this happens only for some combinations, and the order doesn't matter for certain combinations, and it do matters for certain combinations. So now we have to know what is this order, rules, all those things, right? So before getting into it, we'll look into the key characteristics of partially commutative production system. They have selective order dependency, they are rule specific commutativity, and they are adaptable. So what are the rules that can be classified into? The rules can be classified into commutative rules or non-commutative rules. Commutative rules means any order you apply, you get the same result. But non-commutative, the order in which you apply will give different at the intermediate or at the final stage. So an example would make our concept clear understanding. Let us take a simple bank account system where I have four facts. I have a balance of 100 rupees, a deposit for 50 rupees. For every, I'm going to withdraw 20, and for every transaction, I put a service fee of rupees 5. So here it is in dollar, we'll stick on to rupees. So the rules that are there in our knowledge base, I have three rules. Whenever you add or deposit, right? Whenever you deposit, you add amount. Whenever you withdraw, you subtract or deduct amount. And for service fee, it is for subtraction, but for any operation. So the first rule, which it's collection of rules. So let me take rule 1 and rule 3. And when we take rule 1 and rule 3, it falls under commutative set of rules, right? So because applying them in any order will result in the same final result. Say suppose I deposit first 100, some 50 rupees. So my balance is 100. I deposit 50, I get 150 total. And for this operation, for every operation, I have to deduct the amount. So for this deposit operation, I am applying service fee. Service fee is for 5 rupee. So out of 150, I reduce 5 and my balance is 145 now. And if I am going to apply the service fee, right, first, the order in which I'm going to apply. Say suppose here I am applying after deposit. Now I apply before deposit. I have 100 rupees. I apply service fee. So no 5 rupees is going to be reduced, and I deposit 50 rupee. I still get 145 rupee. So here the order in which you apply is not going to change the final answer. But if it is going to be non-commutative combinations, right, then it is going to give different answers in different stages. So let me consider rule 2, which is withdrawal, and this is non-commutative. Let us see it. Okay, I have my rule 2 applied. So I have 100 rupee. Rule 2 is withdrawal, 20 rupee. 100 minus 20, I get 80 rupee. And then I plan to deposit. So deposit 50 rupee. So 80 plus 50, it gives me 130 rupee. And for this transaction, I put a service fee. I have done both the things together. So service fee is 5 rupee. So 130 minus 5, it gives me 125. And now if it is going to be applying the rule 1 first, say suppose, what is my rule 1? Add a deposit. Okay, after depositing, how much I get? 100 plus 50, I'll be getting 150, and I'm going to withdraw. Out of 150, I'm going to subtract 20, I get 130, and then I put service fee, I get 125. Here, see, like if you see, the final answer might be the thing, but the order which you apply, it might give you intermediate results that are changeable. Type 3, non-monotonic production system. The first type is monotonic system. What happens that you can add new facts. You can only add. You can't do anything with the one which is already there. So as new information becomes available, you keep on adding it up. So though the previous ones are to be overwritten, it cannot be done. Here what happens in your non-monotonic production system is facts can be changed, or sometimes you also get it back, retract. Okay, you either remove or revise the conclusions, right? So this is very useful in real world situations because our knowledge keeps on evolving. Day by day, every fact we come to new facts. So my knowledge base always grows as the knowledge events. The key features of non-monotonic production system are revisable facts, new evidence. If it is going to contradict with the previous conclusion, then we have to change with the previous conclusion. And second one, dynamic knowledge. It adjusts the knowledge base in response to the new facts. Your knowledge evolves and it increases the flexibility because uncertainty or incomplete knowledge can be further refined. An example for non-monotonic system is smart home control, smart home climate control system. So it has few rules, right? To say if the temperature inside the house is 75%, then turn on AC. If it is below 68%, then turn on heater. If the user is at home, then adjust it according to personal preference. All these things are fine. Okay, but see the scenario. I have my house. This house is going to be smart house. A person is peeping into it. Okay, all these rules can be applied. And now the person is leaving. Now, in my rules, there is no rule stating that if I go, it should be switched off. It's only for adjustments. So now what my system should be capable of doing is, the system should be capable of identifying that there is no person inside the house. And the fourth type of commutative production system. Fourth type is commutative production system. Here the order of rule application does not affect the outcome. The sequence of applying the rules is immaterial. The system will always arrive at the same final conclusion. So the key features: orders does not matter, consistency and parallel rule execution is supported. So order does not matter means you can apply the rules in any sequence without affecting the final result. Consistency means the system's behavior is predictable and consistent. It makes it suitable for tasks where the order of operations is flexible. Parallel rule execution means there can be multiple rules that has to be applied simultaneously. So you can execute them simultaneously. The order does not impact the outcome. Example for commutative production systems are water jug problem. This water jug problem can be solved either in a depth first search method or in a breadth first search methodology. Thanks for the video lecture 6. It ends here. Thank you.